Welcome everyone. Today we are going to discuss about recursion. So recursion is the process of repeating items in a similar way. In programming languages, if a program allows you to call a function inside the same function, then it is called a recursive call to the function. So basically, if a function calls itself repeatedly until some condition is satisfied, then it is known as recursion. So if you see this example, we have this particular function. The name of the function is recursion, and inside it, it is calling itself. So this function will keep calling itself until some condition is satisfied. So this is known as a recursion function. So whatever functions we have learned till now, those are not recursive in nature, but in this video we are going to see some examples of recursive functions. So what are the advantages of recursion? So first one is the code may be easier to write. It is used to solve problems which are naturally recursive in nature, such as Tower of Hanoi. So Tower of Hanoi is a very famous problems in computer science. So you can go to Google and check out more about Towers of Hanoi. So this is a recursive, so this can be solved by using recursive functions. Now third one is it reduces unnecessary calling of function, and it is extremely useful when applying the same solution many times. So let us see what are the disadvantages. First of all, the recursive functions are generally slower than non-recursive functions. It may require a lot of memory space to hold intermediate results on the system stack. Then it is hard to analyze or understand the code. And last, it is not more efficient in terms of space and time complexity. So these are the disadvantages of using recursive functions. Now we are going to see some programs where recursive functions are used. Let's go to Dev C++. Okay, the first program that we are going to discuss is how to find out the factorial of a number using recursion. So first we are going to write #include stdio.h. Now we are going to declare the function. So the return type of the function will be integer. Let fact be the name of the function, and I will pass one argument for this. Let it be int. Okay, so this is my function main. Since argument is present, I will have to declare the argument here itself. Let it be number. Printf, enter a number, scanf, %d, comma, ampersand number. Now I'm going to call the function, and this is going to return give some return type. So I will have to give the return type here itself. So factorial is, here I am going to, in this %d, I am going to call the function which is fact of number. So how to write a program where return type and arguments both are present, we have already discussed in the last video. So the same procedure I am following. So just here, since it is a recursive function, so what I write inside the function is going to differ. So fact int, let it be number. So now I will have to write a recursive function. So let's write it. I'll explain how it is done. I'm just writing this one, else. Okay, see, so what will happen here? So this is my recursive function. So whatever I wrote to find earlier to write to find out the factorial of a number without using recursion, the code was different. So here it is little bit different. So suppose the number whose factorial I want to find out is 3. Now what is the factorial of 3? 3 into 2 into 1. Now see how it is working here. Now if 3 is greater than equal, so here I have passed 3. If 3 is greater than equal to 1, what you are going to return? Return number into fact into 3. So 3 into Again I will be calling the function, but this time number minus 1. So 3 minus 1 is 2. It means I am calling the function again. I am calling fact of 2 now. Okay. Now when I call fact of 2, 3 already present. Now when I call fact of 2 again, my here this function will be called again. Now what is passed here? 2. Now 2 is greater than equal to 1. What you are going to return? 2 into fact of 2 minus 1. So 2 into fact of 2 minus 1 means 1. Okay. Now this time it is 1. So let's make it if it is greater than 1. Okay. Now I am sending 1 here. Now is 1 greater than 1? No. So I'll go to the else part. What I'm going to return? 1. So next time what will happen? 3 into 2 into 1. So what is the answer? 6. So finally 6 will be returned here. So here we are going to get 6 in this answer. So this is how recursive function works. Now let us save and run it. Okay, go to execute, compile and build. Suppose I am giving 4. So factorial is 24. So this is the code to write down the recursive function to find out the factorial of a number. Okay, so now we are going to do another program. Here we will try to print the Fibonacci series. Now what do you mean by Fibonacci series? The output will be something like enter limit. So if I say suppose 5, it means I need to print the first 5 numbers of the Fibonacci series. So if you see a Fibonacci series, the first number is always 0, second is 1. Then what is 0 plus 1? 1. That is, it adds the previous 2 numbers. Now first 2 numbers will be 0, then 1, then 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5. So like that it goes on. So if I give the enter the limit as 5, it means I need to display 5 numbers, 1, 2, 3, 4, 5. So till this number I need to display. So I need to display this Fibonacci series using recursion. So let's see how we can do it. So first of all, hash include stdio.h. Now I need to declare my function. So I'll be using function with return type and with arguments. Let it be in name of my function Fibo and then again in. Okay, then main. Now I will be needing one variable. Let it be limit. Okay, printf enter limit. Okay, then scanf %d comma ampersand limit. Okay, now I'm going to now I'll be printing the result. So each time I call the function, a particular element using recursion should be displayed, right? So I'll be using one for loop. So I can write down printf Fibonacci series is, just so that it looks good, I'm writing this line. Now I'm going to use the for loop. How many numbers you want to display from I equal to suppose 1, I less than equal to limit. This many numbers you need to display. So each time you call the you go into the loop, you are going to print the Fibonacci series for that particular number. Okay, so I'll be calling the Fibonacci series here. Fibo is the name of my function and I'll be calling it I. Okay, so that's it. Now so till this part it is clear. Now I need to define the function. So when I write it for the first time, let us give it 0. Let's start with 0. Okay, so now I need to define the function. So I'll write down int n. So when the number that I pass, first time when I pass, what it is? 0. So if I pass 0, what should be displayed? So if n is equal to 0, so obviously the first number is what? 0, right? The first digit of the series is 0. So I'll write down return 0. Then else if n is equal to 1, that is the second number, then what is this is permanent, right? So return 1. Okay, then else from the next numbers we are going to add the previous two numbers, right? So I'll be writing return. I'll be calling the function again n minus 1 plus Fibo of n minus 2. That's it. I can give one bracket here and I can give another bracket here. So what will happen? Suppose I have entered 5. So for here I equal to 0. So Fibo of 0 I am calling. So what will be returned? N is equal to 0. So 0 will be displayed here, right? Then again then we will increment the value of I. Now it is 1. For 1, what is Fibo of 1? It is 1. So 1 will be displayed. Now it is 2. 2 is less than 5. So I am calling Fibo of 2. Fibo of 2 means it will go to this part. So Fibo, so what we have already got? We have got Fibo of 0 is equal to, how much we got? 0. Then we already got Fibo of 1 is equal to 1. These two we already have. Now we are trying to find what? Fibo of 2. Now what is Fibo of 2? Fibo of 2 minus 1 is 1, Fibo of 1 and Fibo of 0. So what is Fibo of 1 and Fibo of 0? Fibo of 1 is 1, Fibo of 0 is 0. So what is the answer? 1. So what is displayed here? 1. Again you increment the value of I. Now what is the new value of I? 3. Now 3 is less than 5. Again we are going to enter. Now we are trying to find what? Fibo of 3. Now what is Fibo of 3? Here we are passing 3. So we will go to this part. Fibo of 3 is Fibo of 2 plus Fibo of 1. What is Fibo of 2? 1. What is Fibo of 1? 1. So Fibo of 3 is 2. So that's how we are going to display the Fibonacci series. So let's save it and then run it, execute, compile and run. Okay, we got one error here. I have not declared I. So let's declare I. Save it again, compile and run. Enter limit, suppose 6. So these are the numbers that we got. 6 numbers is displayed. The last program that I want to discuss is to find out the power of a number. Suppose 2 to the power 3 or 3 to the power 4, anything. Okay, so base and exponent will be there. So let's write first hash include stdio.h. Let me show the output. So enter base and exponent. So suppose I am entering 2 base and 3 exponent. So what is 2 to the power 3? It is 2 into 2 into 2. That is 2 multiplied 3 times. So answer is 8. Okay. So this is the answer. So now let us write down the function. So here in this particular program, how many inputs we will be, how many arguments we will be needing? We will be entering 2 inputs, so we will be needing 2 arguments because I am going to use function with return type and with arguments. So return type, let it be int. Then name, I can give any name I want, so let it be what to give, find. Then base is there, so 2 int is there. Okay, one is for base and another is for exponent. Main, so int base and expo. Printf, enter base and exponent. Scanf, 2 times percentage d I will write. So first one for base, second one for expo. Okay, now I'll be displaying the results. So power is percentage d. I'll be calling the function here. Name of my function is find, base and expo I will send. Okay, now I need to define this function. So I'll write in find, int for base let it be b and for this let it be e. Okay, so now I need to write down the recursive function for this part. So here if power, what will happen if power is equal to 0, and what will happen if power is not equal to 0. So obviously if the power is equal to 0, what will happen? Any number to the power of 0 is 1, right? So I will have to check if power is not equal to 0, then what to do, right? So if e is not equal to 0, If it is not equal to 0, then we are going to call the recursive function. So we are just going to write down return base into, we are going to call the function find. Again we are going to, I'll explain in how it is done. Find base into comma e minus 1 else. So now we will be coming to the else part. So else means if power is equal to 0. So if power is equal to 0, obviously we are going to return 1. That's it. So now see how it is working. Suppose what base I have entered. Base is equal to 2. So this is my base and this is my exponent. Okay. So now 2 here and 3 here, right? Now e is not equal to 0. So what we are going to return? We are going to return b into find. So what is b? 2 into find, again 2 comma e minus 1. E is what? 3. 3 minus 1 is 2. So this we are going to call this function again, right? So when we call the function again, this time what we are passing? 2 and 2. So now e is not equal to 0. So again what we are going to, already 2 we had. So what we are going to return? We are going to return this. So what is this? 2 into find 2 comma e minus 1. So what is e minus 1? 2 minus 1 is 1. So this time what we are calling? Find 2 comma 1. So here also e is not equal to 0. So again what we are going to give? We already had 2 into 2. This time again 2 into find 2 comma 1 minus 1 is 0. Okay. Now this time what we are sending? Find of 2 comma 0. So here e is not equal to 0 is false. So we are going to go to what? This part, else 1. So here finally what we have? 2 into 2 into 2 into 1. So what is the answer? 8. So this is how this recursive function is working. Let's delete this part, save it, and then go to execute, compile and run. So base, let it be, let us find 3 to the power 2. So what is 3 to the power 2? 9. So these are all the programs that I wanted to discuss. Thank you.